All right. Today's lesson is identifying proportional relationships. And again, this is a 7th grade lesson that I'm adding to the middle of chapter 5. Here's the homework. Page 5 to 7, we're going to enter in the CPS for a 10-point grade, and page 8 is a 2-point grade. Here are the answers to last night's homework. Pause that and check it. And then here's the rest of the homework. You can pause and check. All right. This is the 7th grade homework note packet that I gave you. We are talking about identifying proportional relationships. We are going to spend the next few days talking about what a proportional relationship is. Let me give you a brief overview. A proportional relationship. This is the X, Y plane, and we're talking first quadrant. Proportional relationships are only in the first quadrant, and they are straight lines that go through the origin. A proportional relationship is a straight line through the origin. That's what they look like. A straight line through the origin. And when one quantity increases, so does the other. So as X is getting larger, so is Y. Now, the constant of proportionality is the unit rate. It is also called the rate of change. Constant rate of change, constant of proportionality, and unit rate all mean the same thing. It is called K. In 7th grade, we use K for the unit rate, constant of proportionality, and rate of change. When we get to algebra, the algebra part of this, in a week or two, we're going to call it M for slope. It's the same thing, except these graphs only go through the origin. Now, you find K by doing Y over X. You need to know that. And I'm telling you right now, your homework tonight, you need to know the constant of proportionality is Y over X. This equation is how you write an equation of a proportional relationship. Y equals Kx. Now, let me show you something. These two things are just different forms of the same exact equation. Because look, what if I divide both sides by X? Don't I get K is Y over X? They're the same equation. This one is how you actually write an equation of the relationship. This is how you find the constant of proportionality. But they are different versions of the same exact thing. Now, let's take a look at some examples. These are really, I think that this is a very easy concept. I'm sorry. A scientist recorded data by a rover sent to the planet Mars. The scientist recorded the time it took the rover to travel to several different distances. Now, in this table, time in seconds and distance in centimeters. Which one of these values do you think is going to be X? Which would common sense tell you would be X? Yeah, the one that's listed first. X, Y. When you have a table of values, X is always first. If it's this is a horizontal table. If we have a vertical table, it's X, Y. But a horizontal table would be X, Y, right? So, calculate the constant of proportionality. Now, there are two things to know about this. The constant of proportionality, unit rate, rate of change, is K equals Y over X. We can calculate that for any ordered pair, but to check check and see if a set of data is proportional, every ordered pair has to have the same unit rate. So my first ordered pair, K, would be 10 over 2. My second one would be 30 over 6. My third would be 15 over 3. My fourth would be 45 over 9. And my fifth would be 20 over 4. Now, I think that every single person in this room, you guys are good with numbers. You can see that every single one of these is going to be 5. Right? They're all 5. So, our unit rate or constant of proportionality or rate of change is 5. 5 what? Look at our labels. Charlie. 5 centimeters per second. 5 centimeters per second. Not only does y over x give us our unit rate, it also gives us our label. Because remember, a rate needs to have a label. So, it is proportional because every unit rate, constant of proportionality, rate of change is the same. Who can give me the equation for that set of data? Done. Y equals 5x done. Bingo bango. Done. Easy enough? Now, let's look at this one. The number of bracelets that Reese can make in X hours is represented by the equation y equals 3/4 x. Complete the table of values below. So, hours is going to be which variable? What's hours going to be? Hours is x, bracelets is y. I'm just going to write it there so we can keep it straight in our head. If we work for 1 hour, how many bracelets can I make? Well, 3/4 times 1 is 3/4. If I work for 2 hours, it'll be 3/4 times 2 is what? 3/2. Or 1.5. If I work for 3 hours, 3/4 times 3 is 9/4, 2 and 1/4. And if I work for 4 hours, 3/4 times 4 gives me 3. So, they gave us the equation. I can find whatever output I want by plugging in an x value, an input. That's where this is related to what we're doing in Algebra 1. X is the input. That's my domain. Y is my output. That's my range. Now, calculate the constant of proportionality. My friends, do we need to do any calculation here? What is the constant of proportionality? Taking a look at what they gave us. No, that's the equation. What is the constant of proportionality, Justin? K is what? 3/4. K is 3/4. I don't need to do any calculation because they gave us an equation and the equation has K. It's 3/4. So, what does this ratio tell me? What is 3/4 based on our table? It's bracelets per hour. Write an equation while there gave us that. Y equals 3/4 x. Is this proportional? Yes, indeed it is, because they gave us the equation. Y equals 3/4 x. Any line that is in that form is proportional. Okay, here we go. Calculate the constant of proportionality for this mapping diagram. It's just a different way to show ordered pairs. Well, isn't K y over x? Let's plug this in. We'll have 3 over 9, 4 over 12, 5 over 15, 6 over 18, and times 7 over 20, well, why am I writing 12? 7 over 21. What does every single one of those reduce to, Justin? It is the constant of proportionality K is 1/3, and it is the same for every set ordered pair. So is this bad boy proportional? Yes, it is. All right. A school dance committee purchased party favors for the school dance. Information about the purchase is shown in the table below. Calculate the constant of proportionality, which is K equals Y over X. Again, the first one is X and the second one is Y. So, my constant of proportionality is going to be 5 over 10 for the first pair, 10 over 20, 6 over 12, 8 over 16, and 4 over 8. Every single one of those reduced to 1/2. So, is this proportional? Yes. Tell me what the ratio tells me. Cost per item. And what will the equation be, Justin? Y equals what? What?
Oh, 1/2.
Correct. Y equals 1/2 X. Now, all of the ones we've looked at so far have been proportional. Let's take a look at this. We've got two relationships shown here. We want to create a table of values and figure out if the relationship is proportional. When you create a table of values, you can pick any X values in the world you want. I always start with 1. So X is 1, 2, 3, 4. You can pick any values you want, but why not pick the easiest? So, let's plug 1 in. 1 plus 2, Y is 3. So my first ordered pair is 1, 3. We input 1, that's our domain. We output 3, that's our range. We input 2, we output 4. 2, 4. We input 3, we output 5. 3, 5, comma 5. We input 4, we output 6. Now, these, that's a function. Okay? We're talking about functions in chapter 5. Kids hear the word function and they start freaking out. A function is just a rule. You input something, you output something. Domain, range. Now, let's take a look at this particular function. Let's find K. K is going to be, now remember, ordered pairs are X, comma, Y. So, my constant of proportionality for my first ordered pair is going to be 3 over 1. What's my constant of proportionality going to be for my second ordered pair? 4 over 2. Do I need to go any further? No, because are these two things the same? No. So, is it proportional? No. It's not proportional. Now, we should have already kind of clued into that, because isn't the equation here y equals x plus 2? Is that in the form y equals kx? No, so it's not proportional. That is linear, which we'll learn about later, but it is not proportional. Over here, here's our function. Y equals 2x, that's our function. Let's input 1, 2, 3, 4. Our function, 2 times 1, we output 2, ordered pair 1, 2. Input 2, output 4, ordered pair 2, comma 4. Input 3, output 6, 3, comma 6. Input 4, output 8, 2, comma 8. Now, constant of proportionality, remember these are x, comma y, are 2 over 1, 4 over 2, 6 over 3, and 8 over, this should be 4, I don't know why I wrote 2 there, 8 over 4. What do I get for all of those?